Hello friends, today we are going to see a three-dimensional a problem and that we solve using a steady state Schrodinger's equation. Now for that a rigid box, three-dimensional rigid box and the particle inside the rigid box, and for that consider what is the rigid box there. So this is a glass box. Inside one glass ball is there, and if you consider it is now at a rest at the origin. So this is the x-axis, this is the y-axis, and this is the z-axis. When it is traveling along x-axis, traveling along the y-axis, and traveling along the z-axis, means it is a restricted motion inside the box only. So it will not come outside the box, and therefore it is called the rigid box. Okay, and hence this article, third article in Schrodinger's application is a three-dimensional rigid box. That is a particle in three-dimensional rigid box. Okay, and for that if we draw the diagram, then so this is the rectangular. This x-axis and the length of this x-axis is A, this is B, and along the is a C. Outside the box, particle will not be there, and these are the represented in quantum mechanically by applying the potentials. Okay, so inside the box V is equal to 0, whereas the outside the box along this V is equal to infinite. Here also V is equal to infinite. Here V is equal to infinite. Okay, so this side also V is equal to infinite. Means the value of A, it should be the value of the x is smaller than A. So x is smaller than A, then within the box y is the smaller than B. So y is smaller than B, and this value of the z-axis is smaller than C. So this z is the smaller than C. Then the potential V is equal to 0. The potential V is equal to 0. Okay, and outside the box, otherwise this is called the otherwise V is equal to infinite, means outside the box. Okay, so this is our problem. This is the mathematically potential can be written as V equal to 0 within the box, and outside the box is del square psi plus 2m by h bar square E minus p psi is equal to 0. So we consider this is as equation 1. Now what are the exercises? So one is the rigid box concept, another exercise to find out the eigenvalue, energy eigenvalue, and third one is find out the eigenfunction, corresponding eigenfunction, and from that energy and eigenfunction and eigenvalues we will see what is the concept of degeneracy. Okay, so first one we solve this expression, this Schrodinger's equation apply for this three-dimensional box. Okay, so inside the one is V is equal to 0, and we write this is a del square psi plus 2m by h bar square E psi is equal to 0. As usual, I put this is equal to say k square, and therefore this del square psi plus k square psi is equal to 0. Now this del can be written as, so this is the d2 psi by dx square plus d2 psi by dy square plus d2 is psi by do z square is a del plus a k square psi is equal to 0. Okay, so is 0. Now we can say that psi, this d2 psi by dx square, d2 psi by dy square, d2 psi by dz square. Now transfer this on either side, and this becomes written as is equal to minus k square psi, minus k square psi, and therefore this is the only function of a function of x. So this is the a function of y, and this is the function of z, is equal to some constant k square. Okay, so this expression can be solved by our a separation of variable method that we have already known, and for that we consider as a psi of x, y, z is a total psi is equal to a psi 1 of x into a psi 2 of y and a psi 3 of z, and therefore psi is equal to a psi 1, psi 2, a psi 3. Put this psi is equal to psi 1, psi 2, psi 3 in all situations, and we have this d2 is psi 1, psi 2, psi 3 by dou x square plus d2 psi 1, psi 2 is psi 3 dou y square plus d2 psi 1, psi 2 is psi 3 dou z square is equal to minus k square psi 1, psi 2 is psi 3. Okay, here differentiating, so this is the only function of x, this is function of y, function of z, and therefore so this psi 1, psi 3 is a constant for this term, and therefore here psi 1, psi 3 d2 psi 2 by dy square plus first and psi 1, psi 2 d2 psi 3 by dz square minus k square psi 1, psi 2, psi 3 as it is. Okay, so divide throughout this expression by a psi 1, psi 2, a psi 3. This is cancel. Here psi 1, psi 2 cancel. Here psi 1, psi 3 will cancel, and plus 1 upon psi 2 a d2 psi 2 by dy square plus 1 upon psi 3 a d2 psi 3 by dz square is equal to minus k square. Say this is expression 1, then we called as so this is a 3, okay, then we called as 4. So see, so now it is a pure function. So this first term is the only function of x, second term is the only function of y, third is only function of z, is equal to some constant. Okay, that means this k should be a k is equal to, or k square is equal to k1 square plus k2 square plus k3 square, where k1, so this is equal to minus of k1 square, this is equal to minus of k2 square, and this is equal to minus of k3 square. So there are the three constants. So we consider only this first term, 1 upon psi 1 d2 psi 1 by ds square is equal to minus k1 square. So we solve this and then we go for the another term. So the first term is 1 upon psi 1 d2 psi 1 by dx square is equal to minus k1 square. You transfer this psi 1 in either side, so minus k1 square psi, then bringing in either side we'll get d2 psi 1 by, so this is the d2 psi 1 by dx square plus k1 square psi 1 is equal to 0, say equation 5 is equal to a psi 1 of x is equal to a1 sin k1x plus b1 cos k1x. So this is a sixth sign, where the a1 and b1, these are the constant, and that can be determined using the boundary conditions as we have seen in last time. So first boundary condition, at x equal to 0 is psi 1 of x is equal to 0. So this is the first boundary condition, and therefore this becomes 0 is equal to a1 sin x equal to 0 means 0 plus b1 x equal to 0, so that is cos 0. So this cos 0 is equal to 1, sin 0 is equal to 0, and therefore this b1 is equal to 0. Put this value of the b1 equal to 0 is here, and therefore we have this a psi 1 of x is equal to a1 sin k1x is expression 7. Okay, so this is from the first boundary condition. So there is another boundary condition from that at x equal to a, psi 1 of x equal to 0, and therefore a 0 is equal to a1 sin k1a is equal to 0. Okay, and therefore here there are the two terms. One is the sin k1a or a1. So either a1 is equal to 0 or sin k1a is equal to 0. Okay, and therefore a1 cannot be 0 because you are particle inside the box, and therefore the probability inside the box is not equal to 0. Okay, and therefore this a1 not equal to 0. If the a1 not equal to 0, that means sin k1a is equal to 0, and therefore sin k1a is equal to 0. If sin k1a is equal to 0, sin k1a is equal to 0, so what is the value of the k1a? So this k1a is equal to n1 pi. So we term as the 1 n1. Okay, and therefore value of the k1 is equal to n1 pi by a. Value of the k1 is equal to n1 pi by a. Okay, and therefore this expression 7 is written as a psi 1 of x is equal to a1 sin k1, and k1 is value k. So this is the n1 pi by ax. N1 pi by ax. So this is the expression 8. So this is for us. This what is the value of the a1? A1 is the nothing but your normalization constant, and that normalization constant here we will not derive it, but it is root 2 by a that we have last time we have seen, and therefore this psi 1 of x is equal to root 2 by a sin of n1 pi by a x. So this is your final expression for the first term of this equation, last one. So this is psi 1 x is equal to root 2 by a sin n1 pi by a x. Similarly psi 2, so this is a psi 2 of y is equal to root 2 by a. Instead of the a, it is b. So this is the b sin n1 so this is the n2 pi by b y 10, and a psi 3 z is equal to root 2 by c is sine of n3 pi by c z expression. Psi x y z is equal to psi 1 of x is psi 2 of y and psi 3 of z. Okay, and therefore this psi x y and z we term as psi n1 n2 n3 is equal to psi 1x. So psi 1x is equal to root 2 by a sin n1 pi by ax root 2 by b sin n2 pi by by, and third term root 2 by c is sin n3 pi by c z. Now this term you combine and you can write root 8 abc a sin of n1 pi by ax sin n2 pi by by a sin n3 pi by c z. So this is a sin n1 n2 n3. So this is your say equation 12. Okay, so this is the eigenfunction value. Another one, so that eigenvalue we are going to see, and this can be considered as, last time we have seen this energy k square is equal to 2m by h bar square 2me by h bar square is equal to k square. So that is the value of the k square. But why this k square is equal to what? This k square is equal to k1 square plus k2 square plus k3 square. But we have known that the value of the k1 is equal to, so this is the n1 pi by a, so this is the n2 pi by b, and this is the n3 pi by c k, and therefore the square of this and this square plus square plus square, and therefore this k square is equal to n1 square pi square by a square plus n2 square pi square by b square plus n3 square pi square by c square. You take common pi square here, so this k square is equal to pi square into bracket n1 square by a square plus n2 square by b square plus n3 square by c square. Okay, and k is 1, k square is nothing but, so this is the 2me by h bar square is equal to pi square into bracket all this thing. So this is the n1 square by a square plus n2 square by b square plus n3 square by c square. Okay, and therefore the value of E can be written as E is equal to transfer this h for another side divided by 2me. So this h bar square pi square divided by 2m into bracket n1 square by a square plus n2 square by b square plus n3 square by c square. So this is for the energy. Okay, so the energy for the n1, n2, n3, and this is the eigenfunction. So eigenfunction for this n1, n2, n3 is equal to given by the equation 12, whereas the eigenvalue, energy eigenvalue E n1, n2, n3, n1, n2, n3 is equal to say 13 is given by this equation. So this expression. So is equal to h bar square upon pi square by 2m, n1 square by a, n2 square by b, and n3 square by c. So this is your the eigenvalue, energy eigenvalue for the a three-dimensional box. Okay, and this is the energy eigenfunction for the particle in three-dimensional box. For simplicity, we are considered, so that box is nothing but cube. That box is nothing but the cube, and therefore, in case of the cube, A is equal to B is equal to C, and therefore these formulas can be converted as. So for the cube, all sides are equal. A equal to B is equal to C. And therefore, these two equations can be written as. And so this is the sine n1, n2, n3 for cube is written as 8 ABC divided by A cube into sine n1 pi by a x as it is, sine n2 pi by b is nothing but a again y, and sine this n3 pi by c is nothing but a, so that is the z. So this is the wave function for eigenfunction for cube, and energy eigenvalue. So this is E n1, n2, n3 is equal to a square. This b square is nothing but a square. This c square is nothing but a square, and taking the common outside, and then it becomes h bar square pi square divided by 2m a square into bracket n1 square plus n2 square plus n3 square. So this is the energy eigenvalue for the cube. Okay. Now first we consider the ground state for the cube. What is the both the eigenfunction and eigenvalue. Then first excited state, second excited state, and there is one concept, that is the degeneracy. First we find the energy values. Okay. So for ground state. For a ground state, say n1 is equal to n2 is equal to n3 is equal to 1. Means all state n1, value of the n1, n2, n3 is equal to 1. And for that, write this both equations first, and therefore for a ground state, so this psi 1 1 1 is equal to root 8 by cube as it is into a sine of n1 is 1. So therefore this pi by ax is sine n1 is 1. So this is the pi by ay is sine n3 is 1 pi by a z. So this is the wave function ground state. So this is the wave function for the ground state, and the energy value. So this E111 is equal to, so this 111 is equal to this h bar square pi square divided by 2m a square into bracket n1 square 1 square plus 1 square plus 1 square. So 1 plus 1 plus 1, so that is the 3. We write as 3 into so this h bar square pi square divided by 2m a square. So this is the energy value. So there is one eigenstate and one energy. Now the second excited state is given as, and for the second excited state I will write here first excited. So a first excited state, and this can be written as, so n1, n2, n3 is 1, 1, 2, 1, 2, 1 and 2, 1, 1. Okay, and we find out the corresponding energy first. So this is the E, and this can be written as E112. Here E is 121, and here energy E is equal to 211. I will show the first case here. So this is the general formula for this energy for Q. So this is the energy E112 is 112 is equal to h bar square upon pi square 2ma square is as it is, n1 square 1 square. So this is the 1 square, this is the 1 square, and n3 is 2. So this is the 4. So this is the 4, 5, 6. Okay, and therefore this is equal to 6 into h bar square pi square divided by 2ma square is the same. Now, so only the interchange of this 1 and 2 is there. So there are the two terms as 1 and n1 is 2. Here the n1 is 2 and n2 and n3 is 1. Therefore these 6 are the common one, and therefore this is also same. So this is the pi square h bar square pi square divided by 2ma square is same. Here also the 6 into h bar square pi square divided by 2ma square. And therefore in first excited state, energy eigenvalue E112, E121 and E211 is the same. And that is the 6 into h bar square pi square divided by 2ma square. Okay, now we are going to see the corresponding eigenfunctions, what these are, and corresponding eigenfunctions we write as the sine 1, 1, 2, another is a sine 1, 2, 1, and sine 1, sine 2, 1, 1 is equal to, let us see what happens. The general formula for sine is this one, and therefore the sine is equal to root 8 by a cube is common sine, and n1 is what? n1 is 1, n2 is 2, and n3 is n1 is 1, n2 is 1, n3 is 2. So n1 is 1, n2 is 1, and 2. Here it is a 2, and therefore what happens here? So this is the sine of pi by ax, a sine of pi by ay, but the n3 is 2, only the sine of, so this is the 2 pi by a z, only the third thing. Now second state is 8 by a cube is common as it is. So here it will become only the remaining same sine pi by ax, here a sine 2 pi by ay, here it is 2, and sine same is pi by az, and first term will change. So this is the 8 by a cube sine only 2 pi ax, same sine pi by ay, sine pi by az. Okay, so there are the three eigenstates. So one is the represented as the sine 1, 1, 2, another is the sine 1, 2, 1, and this is the sine 2, 1, 1. So there are the, in first excited state there are the three states. whereas the corresponding energy eigenvalue is the same. Energy eigenvalue is the same, and therefore this is called a degeneracy when there are the one single value of the energy corresponding more than two states, more than one state. So there are the three states. There are three states in first excited state: psi 1 1 2, psi 1 2 1, and psi 2 1 1. And corresponding energy value is only one, and therefore this is called a degeneracy. And degree of degeneracy is what? The degree of degeneracy is the total number of the states. Here the total number of the states is 1, 2 and 3, and therefore this is called threefold degeneracy. So the first excited state of a cube, particle inside the cube, has a threefold degenerate. Okay, so degeneracy, degree of the degeneracy is a 3, and therefore it is called a threefold degeneracy. Corresponding energy is this. And second excited state, for second excited state, so n1 is equal to n2 is equal to n3 is equal to 2. Okay, and therefore find out the first psi 1 and then energy eigenvalue. First to find out the energy eigenvalue. So this is the E222 is equal to, so here is 2 square 4 4 4. So total is the 12. This is equal to 12 h bar square pi square divided by 2m a square. 2m a square. And therefore energy eigenvalue for the second excited state is E222 is equal to 12 h bar square pi square divided by 2m a square. Okay, and corresponding eigenfunction is sin 222 is equal to this is the general formula. So this is the root 8 by a cube as it is into sin the value of the n1 into n2 is, so this is a 2 and 2, and therefore this can be written as sin 2 pi by x sin 2 pi by by sin 2 pi by c. So this is the eigenfunction. So eigenfunction is only one, and energy is also one. So the second excited state is a non-degenerate. So second excited state is a non-degenerate. Ground state is also not here also the psi 111 E 111. So ground state and second excited state are non-degenerate states. Okay, whereas the first excited state has a threefold degeneracy. So this is a conclusion from one. So this is the concept of the degeneracy. Like that we can solve physical problems also using this application. So this is the a third application, the particle inside the rigid box. Okay, you got it. So you go on repeating all these values, write this 2-3 times, you will get the in case of the examination point of view, you can write, and this is the very important article in case of the examination point of view.